Circles. Up until now, we've only looked at objects accelerating in a straight line. So we've had an object that starts here and has accelerated over to here and is moving faster or slower than it was before, all in a straight line. But objects can move in other paths than straight lines, and the one we're going to look at here is a circle. So we're going to have a look at how objects can move in a circle. So if you think about acceleration, the acceleration is equal to the rate of change, or is defined as the rate of change of velocity. And if you remember, velocity includes two things. It includes the speed of the object and it includes the direction of the object, because it's a vector. So if anything about the velocity changes, then over time, which is the rate of change, then we can say that the object is accelerating. So if the speed changes, or the direction changes, or both of them change, then we can say that the object is accelerating. Now let's take that, let's pause on that and let's just say that again. If either the speed changes or the direction changes, the other one can actually stay the same. So for example, in this first example over here, we've seen that the direction of the objects is constant, is going in the same direction all the time, but the speed is changing. Here we've got it going more slowly, and here it's going more quickly. So the speed has changed, but the direction hasn't changed. Now consider this object down here. This object down here is going at a constant speed. If we draw the velocity vector for this one here, we can see that the velocity at that particular instant, the object is headed in that direction at a certain speed. Around here, when it gets to this part of the circle, we can see that the velocity vector is pointing this way. If we could take a snapshot, we could see it was heading in that direction. Around here, it's going down here, and at the bottom here, it's heading off in this direction. So the direction of the velocity is constantly changing when an object moves in a circle, even though its speed might be constant. So here we can say the object has a constant speed, but a change in direction with time. And because the velocity is the speed and the direction combined, and because there is a change in that direction with time, we can say, therefore, the object is accelerating. Okay, now let's look at the direction of that acceleration. The velocity is changing towards the object, or the point in the middle. This might be an object in the middle here, like if it was a planet orbiting a star or whatever, or it might just be a point in space. There might not be an actual object there. But the point is that that object is being pulled in towards that point in the middle as it rotates round in a circle. So the direction of the acceleration, that's the direction of this arrow here, is pointing towards the centre. So we can say that the acceleration is towards the centre. This is slightly counterintuitive, because when you're travelling around in a circle, it feels like you're being flung outwards. It feels like the force on you is outwards. But that's just a reaction to something pulling you inwards and pulling you in towards the centre of the circle. So for an object travelling in a circle then, the acceleration vector and the acceleration itself points towards the centre. And obviously that is caused by a force. We call this a centripetal force and a centripetal acceleration because it acts towards the centre of the circle. Centripetal is Greek for centre seeking, so it points towards the centre. Okay, just moving down here a little bit. So just to recap, we can say that when an object is going round in a circle, the speed of it can be constant, but because the direction of the object is changing, the velocity is also changing, and because the velocity has speed and direction associated with it, and the direction is changing with time, it means that this object is accelerating even though it's moving at a constant speed. And the highlight is the difference between speed and velocity. Velocity also includes direction, and a change in direction means an acceleration. So what factors affect the acceleration of an object going around in a circle? Well, there are three factors that affect the acceleration. Number one is the mass of the object, how big it is, how heavy it is as it moves around in this circle. Number two is the velocity of the object. So that's these V's here, how fast it's moving round in the circle. That's an obvious one. And the other one is the radius of the circle, i.e. how far the object is out from the centre. So we've got the radius of the circle, we've got the velocity of the circle, and we've got the mass m of the object here as well. And all the three of those factors affect the value of the acceleration required, and therefore the resultant force on the object towards the centre of the circle, the centripetal force, how large that force needs to be to keep the object moving in a circle. So when all these factors, when the mass increases, when the velocity increases, but when the radius decreases, all of those three things happen in that way, that will mean the acceleration will need to increase in order to keep the object moving in a circle. So a heavier mass, a higher velocity, or a smaller radius, that's the one that maybe isn't quite so obvious, will all lead to a larger centripetal acceleration.